Okay, I think we can start. Hello everyone, I am Pramod Rana and welcome to the talk. Today I am going to talk about how to have visibility and security of CI/CD ecosystem. Uh, this is the agenda short. So first I am going to set the context that why I am having this talk. Second, the attack surface around the technology, and then what methodology we can have in order to secure that. And then I'm going to introduce CI/CD Guard, which is an open source project around the same problem. We are going to deep dive into architecture and workflow of that. I have a short demo after that, and then I'm going to close with the feature expansion of that. A bit about myself. I'm working as an application security manager with Netscope. I'm author of 3 open source products, recently Brandlizer and Security, which I have presented in different conferences like Black Hat, DEFCON, NullCon, OS, Global AppSec, and all that. I'm also OS Pune chapter lead and proud OCP. Setting the context, for any software in the world, we have a certain code base which is stored in a central location for collaboration and access to the everyone. And then we have a solution which converts that code into a deployable entity, which is again stored in a central location. And then we have a solution which basically distributes that entity into different infrastructure. That's a very high level and oversimplified version of a CI/CD ecosystem. And as a DevSecOps advocate, I highly recommend every software organization to have security integration into each phases of the security, this SDLC process, which is security in CI/CD, as we all know it. It's a great topic, but today we're not going to talk about that. Today, we are going to talk about securing the building blocks of that overall CI/CD ecosystem, which is, I call it security of CI/CD. So this talk is more about the builder part of it rather than being the breaker part, like most talk in at Miami. So in today's time, there are a lot of tech tools and technologies which is building a CI/CD ecosystem as per the organization, as per the product, as per the sector they are working on, and most of the technologies falls into more than one area of work. And like any ecosystem in the nature, even the compromise of single unit of the ecosystem will have impact on the overall part of it. Just put that here. And yeah, I was saying compromise of even single component will impact the entire ecosystem. Part of the problem with that, with CI/CD technology today is the visibility, like most areas in the security. So for as an organization, I might be aware that I'm using, let's say, GCR Artifactory in my system, but do I know how many artifacts are actually there in the system? And even if I'm aware of that fact, do I know that which version of artifact is actually installed in the system? And another area could be, for example, I might be aware that I'm using GitHub Actions, third-party GitHub Actions in my organization, but do I know which version of those actions I'm using in my organization? So that visibility makes our security more complex, and in most areas of the security starts with the visibility of that. So if you look at the attack surface, or if you look at this first point, at first it might look a very trivial point that we were able to add the insecurity Jenkins, which is building which is responsible for the build process of our thick client. But now, if we look at the business part of it, if that binary is getting deployed into the customer segment, then even the compromise of a very trivial system like Jenkins will impact on the customer data directly. So that's what I meant when I said that even the smallest component plays a big part in overall ecosystem. And that applies to multiple things. We might be having, I know there was a talk in the morning about the exploitation of the GitHub action in Hack Miami only, where the researcher showed that how the vulnerable third-party actions can be used for the mining and coin mining and all that. If you are having that action running into your self-hosted runner, so all of these kind of thing adds up. And if we have vulnerable small components running in our environment, then it makes overall a biggest impact on the overall supply chain. It could be like we must have, in your organization you must have a single sign-on feature where one user is authenticated to different applications, and what if that particular user is compromised and that particular thing is impacting multiple services, and it goes so and so forth. Having a compromise of the GitHub service itself might impact the services which are dependent on the authentication of the GitHub. So that's what the relation between the different components come to the picture when we are looking over the overall CI/CD platforms. What could be the methodology? I think there are three parts what we have to look at. The first is about making the software secure by default, and I think in that there are two ways to look at it. The first as a software provider, and other part is as a software consumer. So when I say software provider, it will again ties back to the security and CI/CD part. I think as an industry we are doing a relatively good job when it comes to securing our own product, which we are providing as to our customers. But I think the other area where we are a software consumer, because so in Netscope we have a policy which says that whenever we are onboarding a third party software, it could be a small library doing a very specific job, or it could be an enterprise level software which will be used by each and every employee of the organization. So what we do, we have a vetting process from a process perspective, looking at the software we are onboarding into our organization. And if we identify any vulnerability in that, we consider that as a vulnerability of our own product and make sure that we are working with the vendor in order to make it secure thoroughly. So I think that similar concept applies to the, for example, if you are onboarding, let's say, GitHub Actions in your organization first time. So are you looking at all the aspects of the security of GitHub Actions? Though you are not the provider of that software, you are a consumer, but I think as a consumer also it's our responsibility to look at that. So in the overall methodology, that becomes the first part where we are trying to make the technology secure by default. Like I said, implementing vetting process on an organization level, working with the provider proactively to resolve the vulnerability. The second part of that is a software can be best secure, but if we are not implementing it correctly or rather insecurely, then it's as good as you have the best lock in the world and you have not put the key. So that becomes the second part of it. You have a software, how well you are implementing it in your organization, and these are very, I'll say, simple point which eventually adds up to the overall big picture. It could be default setting disabled. It might sound simple, but even in today's time, we find organizations not doing it very effectively. Like you will find many, let's say, software which is open to world with some default settings, which is very easy to fix, but if not done correctly, then have a catastrophic impact. MF enabled or not, so and so forth, up-to-date plugins. Because if you talk about any enterprise level software, more often than not, they always have a custom configuration which makes that software more configurable and expandable. For example, in case of Jenkins, you have plugins. In case of GitHub Action, you have third-party actions. In case of other software, you have always additional capability to do things. So when you are relying on those third-party things, for example, in marketplace, we have a lot of things. So when you are using it, when you are implementing in an organization, how much due diligence you are doing in order to make sure that those are fall within your patch cycle or whatever vulnerability management program you have in your organization. The third part, I think all of us are in industry long enough to understand and accept that no matter what we do, there will always be a scenario where we have some gaps. And in the case of that gaps is exploited, how well we are in a position to respond to that and act on that quickly and adequately. So I think these are the three areas. First, making sure that software is secure by default. We are putting our best as a software provider and as a software consumer. Second part is whatever software we have, are we making sure that it is configured and implemented securely. Third part is all done well. If something bad happens, then how well we are positioned ourselves to respond on that. And that leads to the introduction of CI/CD guard. So what CI/CD guard does, it first, it converts or rather represents each and every component of the CI/CD into graph forms. And what I mean by that is each technology is break down into the granular level possible, and each part of the technology represents a node, and then there is a relationship between these nodes, which helps us to figure out the visibility part. And so if I have to give an example for, if you pick the example of GitHub Action, so it will, how it's going to break down the node part is that it will start with the workflow, and then it will go to the jobs you have, and then it will break down to the steps. Steps is external action, or you are calling a command, in which runner you are running it, what version is you are using it. So what it does is it breaks down each technology into the most low level details of the technology, which helps us to identify that how many kind of variations we have within our environment. And at the same time, for example, in case of artifact tree, it will help us to identify that how many artifacts you have in your system, and what are the different variations of those versions of those artifacts you have in your environment. So first, it breaks down the technology in the representation of graph. I'll show it more in the demo part. Second, obvious thing, it identifies some security flaws within the scope, within the supported technology. So as of today, it supports GitHub Actions, Jenkins, and JFrog Artifactory. I'm working on incorporating more technologies. For all those four technologies, it tries to identify the security flaws, the best practice in industry best practice on that. And third part, which is most important in my opinion, it tries to identify the relationship between the different technologies. So like I said, in the overall picture, no technology is independently deliverable. What I mean by that, the Jenkins server or the GitHub Action on an independent sense is not something we are delivering to our customers in case of any software. It's always the overall picture, how it is getting connected. For example, if a developer is changing a certain line in a code, then how it's getting impacted to the end user, and that will be a overall workflow, that how that code is flowing between the different technologies. So that's what it tries to do. It tries to identify the relationship. For example, if a developer is doing push PR, has opened a PR to a certain repository, then that repository will, let's say, trigger a particular Jenkins job, and that Jenkins job will trigger a particular artifact to be built, and that artifact will be pulled into different infrastructure. So what CI/CD does, it tries to identify the relationship between from the repo to the last target technologies. So it helps us to identify that how the different technologies is building the overall software, and what insecurity in a particular technology is going to impact on what different kind of products. And so eventually the goal is that if a developer doing a particular commit into his or her local laptop, then how it's eventually going to the customer environment. So if as of now it's not in that mature level, but that is the eventually idea where we can figure out that entire map, so that it helps us to identify, make a better triage of the issues we are doing. So for example, if a certain change is impacting our customers most, then we can prioritize on the basis of that. Let's say the example I mentioned, changes in a particular airport triggering a particular Jenkins job. It could be different for each organization, but as and when you start using it for your organization, the better relationship it will be able to make over the time. So the part I'll explain in demo more, because the scanner runs on independent way, and then you have an analysis engine which can build out that relationship. Again, the another use case could be, for example, in our organization, let's say we have a policy which says that whenever you are using the external GitHub action, as a security team, we vet a certain version. So what it helps us to identify is, let's say we say action A version 1 is go ahead from security side. So from the tool, what we can do is how many different version of that action is getting used in our organization, so that we can say that we vetted the version 1 of that particular action, but in our organization we have 5 different versions used as well. So it helps us to build that use cases and identify the relationship and between different technologies. Again, it goes so and so forth, how many users are shared across the environment. There are different test cases. I have just jotted down few one. This is the node database schema. Like I said, I have tried my best to break it down to the lowest level possible. If you will look at Jenkins, it's going to break down to the server, node, job, build, user, plugins, so on and so forth. For example, at any point of time, you might be aware that okay, we have 5 Jenkins in our environment, and out of those, in 5 Jenkins, we are using 10 vulnerable plugins. So it can do that, and it can help to build that use case. And since I have used graph to represent the overall database, it helps the intuitive visualization in that. This is the overall architecture and different component of the CI/CD guard. So first one is the scan engine. So what I have done is this scan engine either can be run on independent manner, or you can run it with the analysis engine. And what I mean by that is this scan engine is essentially a bunch of Python script for each technology. And you might see that I have segregated the technology GitHub versus the GitHub action, because in terms of overall CI/CD, they have different purposes. GitHub is supposed to be a safe, and action is supposed to be a DevSecOps technology. So these are just a bunch of scripts which you can run on independent manner. The authentication detail and everything you can either provide by the command line or by the environmental variable. And because it's possible that you might be using, let's say, 2 out of these 4 technologies. So you are free to use for those 2 technologies only. And again, since these are just command line scripts, you can run it with any kind of technology. Like you might configure action to run these scripts. If you run these scripts independently, these scripts are going to provide you output in the JSON, and those will be specific to those technologies. So, for example, if you provide a JFrog server and run the JFrog scanner, it will give you output for those particular JFrog environment only. The important part, like I said, analysis. So what's going to happen is, for example, if you are running GitHub action in JFrog in your environment, and you let run it with the analysis engine, then it's going to identify the relationship between those 2 technologies. Now, in the future, let's say you added another technology, then it's going to find the relationship between these 3 technologies. So the more and more technology you add, the more and more relationship it's going to identify. And that is what the analysis engine is. From an output perspective, there are 3 ways you can have it. For the analysis engine, you have to have it in Neo4j. Like I said, in the command line, you can have directly in the terminal. At the same time, it's supposed to have the output in the JSON, which will eventually help you. Let's say if you have a use case where you want to put all the output into Elasticsearch or anything, that also you can do it. So all the components of CI/CD guard is designed to run independently, so that there is no hard dependency of running it in a very specific manner. So you can use scripts independently, put it the output in the Elasticsearch, and then directly search it as per you can make a dashboard or something like that. If you want to use the analysis engine, you feed the output to the analysis engine, and it will do the analysis and return you the output in that way. On top of that, it has a very, I'll say, very basic and simple web UI, which helps us to visualize the overall data which it is able to put. From a input perspective, since it interacts with all the in-scope or the target environment, you need to provide authentication and the target environment detail in one way or another. So for that, for example, in case of GitHub, it could be your personal access token or the organization level token. For the Jenkins, it could be API key, something like that. And 2 ways to provide the input. It could be environmental variable, and you can provide it by the command line. Environmental variable is basically supported if you want to run it in another solution in a continuous way. Command line makes sense if you are running it in an ad hoc way. for the demo. I recorded demo for specifically because the environment I was running, I cannot show it in the demo for obvious reasons. So that's why I what you can say, redacted some of the target information. If you will run it in your environment, it will show the actual data you are creating in the environment. So is it visible? It's not visible in my laptop.
Small.
I think the Zoom share section messed up the
Command plus maybe? Command plus maybe?
No, it's just not visible. It's the I mean it's not the size is small, it's
It's
just
the resolution of the projector.
yeah, my laptop is I think.
Your laptop's good. This is probably like an external monitor.
Okay. Okay, I'll try my level best to talk you through. So in this output, you have 4 independent scripts, like I was saying. I remember the order. The first is JFrog, then you have GitHub, then you have Jenkins, and then you have the GitHub Actions. Like I said, you can run these scripts independently. So first, I'm running a GitHub scanner, GitHub Action scanner script, which basically what I'm doing, I have used command line input validation for that. What it is doing, it is just passing the data and creating the node. So so like I said, there are 3 ways to output. At the same time, what it is doing is it's printing on the display in the terminal. It is putting the data into the Neo4j, and end of the execution, it will show the data into the JSON. So this JSON data you can redirect it to your solution where you want to feed it. And so in this JSON data, it contains all the details. For example, what was the vulnerability detected, where it was detected, what is the artifact to support it, so on and so forth. So in a broader section, it has a certain ID for each vulnerability, and then have a vulnerability detail, and then it has the affected area and what is the artifact, why it says that vulnerability is there. And same way, I have run the script for the Jenkins as well. In the output, it's anyway detected now. So so in the Jenkins again, you have a Jenkins server, you have the authentication detail. It is doing the query. I have intentionally not fast forwarded because I just want to explain that it takes certain times depending on the environment reachability and all that. And the process is same, output in the terminal, feeding back to the Neo4j at the same time. In the backend, what is happening is as and when the script is putting data into the Neo4j, it is doing that analysis part where the second part is done. So if you put the data into the Neo4j database, it's by default it will do the analysis. And once that scan is completed, it takes time depending on how much data you have in your target environment. So the Jenkins server I scanned here, it had a lot of data. That's why it will take more time to do the analysis. And once that analysis is completed, it will go to the, it will generate the data, all the data into the JSON form.
So each person who uses this gets their own database, or it's a central?
No, it's its own.
So
If you use, the data will be in your environment.
So the more you use it,
The better analysis
Very
it will be.
so I wonder if like 10 of us combine forces.
Doable, but then I have to host it in a central place somewhere, and
We saw the service.
then I have to charge you.
Business, yes.
Just do it under for NDA.
Start a business.
Hey, here's the username and password.
Like I said, I have intentionally not fast forwarded. I just wanted to show it in the actual execution way. It takes time. It has a lot of data. Again, all of the output is in the JSON. You don't really have to use the Neo4j. It's pretty customizable to use it in an environment. And since all of those scripts are independent scripts, you can run those scripts in any way. I hope the UI is visible. Yes, it's visible. So that's what the basic UI looks like. The more technology you will feed it, and the more technology will scan this graph will become more and more complex. At this point of time, I scanned, I think, few Jenkins, some hundreds of reports for the GitHub Action. and then one JFrog server.
This is graph, they used a directed graph.
Yeah.
This is a neural network. Yes,
So what happens in this case is and then there is a basic filter as of today, which basically helps you to filter out the data you want to see at that point of time, because you do not want to see 1,000 nodes at the same time. You are interested in a particular node at the same time. So you apply the filter. Let's say in Jenkins, you just selected that I just want to see the vulnerable plugins. The color coding is there.
Red is vulnerable, right?
Yeah. So what this graph is telling at this point of time is you have one central Jenkins server which have these many vulnerable plugins in your environment, and each node will contain the detail about which vulnerability is there in the plugins.
So clicking on this will give something? Or?
Yes, yes. Like I said, I have to redacted it. So what happens if you click or hover over it, the data will be displayed.
it goes off CVE.
Yes. So like that way, you can make any kind of filtering on the basis of the UI. It's a core condition at this point of time. So when I select two things, the plugins and build, it says all the nodes which has a metadata Jenkins build or a metadata Jenkins plugins. So it will show all the graphs. So you can just click it, delete it. For the UI, I wanted to show a very specific scenario. So if you look at the color code, each color in a way represents each each individual technology that is basically based on the color of their logo. So for the black, it is GitHub, and for the, I don't know what to call it, some version of blue, it's Jenkins. Now, if you look at this node, it is showing the relationship between the repository and the Jenkins. So which basically tells you that this Jenkins build is getting triggered because of changes in this repo.
These are subgraphs, how come they're not connected?
These are independent graphs. So for example, if I go
Like,
here,
how come one build isn't one big graph?
no, so what is happening in this scenario, I have scanned multiple organization within GitHub. So each central node is an organization in the GitHub.
Oh, gotcha.
So this is one central organization which has associated associated repo, and then that repo is connected to the Jenkins build. Because these repositories were not connected to the Jenkins which I scanned. So next time I will scan a Jenkins which are connected to these repo, they will make connected graph towards that.
So that Jenkins gets more and more nodes off of it over time.
Yes, yes. So let me say this way. For example, I know him directly, and then you know him. So unless I introduce him, there is no connection between you and me.
Mhm.
So once I introduce him, there is a connection between me to him, him to you. That's how it works. So if I'm scanning both of us independently, there is no direct connection between them. So in the same way, since I have not scanned a Jenkins server yet, which has connection to these repository, there is no relationship, external relationship. So once I will scan those Jenkins server independently, they will get fed back to this database. Once they are fed back to this database, they will build the connection. Make sense?
I'm wondering how do we use it?
So the easiest way to start with is you just start using the independent scanner scripts as per your organization.
Fair enough. How do we use this result? How does my security team now, what do they do next?
So in this case, what we have to do is, let's say all of these red nodes, they will have the output in the JSON format. Then you need, so for example, in our case, Jira is the everything where we are tracking the findings. So what we do is that we feed it back that JSON to the Jira ticket, depending on how it is mapped in your organization. So like I could simply write an API call to the Jira, but I know for a fact it's not going to be usable because every organization uses it in a very, very different way. So that's why the JSON, I have stopped writing the script till I have the JSON data. I have let the user to decide what they want to do with the JSON data. So it's going to tell you all of these are vulnerable things. Now it's up to you how you want to consume it. So in our case, we feed it back to the Jira.
that you just ingest it into Elk and then create words that send that off to Jira.
So I use a tool called Mend,
Yeah.
white source, old, well, I don't know what it's called, but it will auto upgrade the dependencies in a repo when they're out of date, when there's vulnerability CVEs. So stitching what he built with what they already have.
Instead of having to go through Jira. Yeah.
There's not even a ticket.
Yeah.
This is a whole pipeline. This is a machine, GNN,
Yeah.
not even machine learning, it's neural network.
So if you look at this, like I said, these are going to show the relationship. These were the two repos which were part of this Jenkins build. So like the color represents this, which we're going to have. And then another example to add to that, what's going to happen, for example, from that Jenkins build, you are putting the artifact tray into, let's say, your GHCR or GCR artifact, and you scan that as well. So what it's going to map is repo to build to artifact. So there is a path between these three things.
Because I spent all this time trying to get Trivy to scan the images as they go into GHCR, GCR,
Yeah.
and so on. But this is even faster. No humans.
But like I said, the true value of this tool comes once you start. The more data it has, the better relationship it will make.
That's any neural
The
network.
better
That's
relationship,
what I'm saying.
yeah,
Everybody.
the better finding it will
I
be.
think you got something here.
So
Gotta be careful with sprite.
No. Oh, you mean the framework?
yeah.
Why, you know what that is?
I thought I heard you say you work for Palos.
I did say that.
Okay.
That's their internal.
Yeah.
Yeah. So this is what it is as of today. I'll say limited technology supported as of today. It's just 4, and market is crowded with all the technologies. Like I'm actively working on, I think, 2 of these, drone and Spinnaker. But I think more and more technologies we add, I might jump into the cloud part also, like I said, ECR, GCR, GSCR, and all that. So the expansion of target technologies, like I said, the better coverage it has, the better relationship it has. I still want to expand on the analysis engine, where the parsing of the component is more comprehensive. For example, as of today, it is just detecting that there is a repo. Is there any way to map it in a way that in that repo we have so many branches, and in so many branches we have so many commits? So the more and more low level details we go to the technology, the more granular control it will help us to build. For example, we might be able to build a relationship that developer A made this commit B, and then that commit B led to certain artifact in the system. Correlation between different repository. I think in world of microservices, I know Amazon made a call to not have microservices, but still, in a world of microservices, like if one microservice is built by 10 different repos, can we look at it that way? That can we add a metadata to the repo which represents a certain microservice? So can we club it that way? I am not able to code it yet, but I have few ideas around that. So again, expansion of the analysis engine, build contributing to particular microservices, like I said, and visualization. Primarily, I'm working on the search engine more, which helps us to make the search on basis of all the metadata associated with the node. For example, I might say that I want to understand the build which is running on daily basis only. So those kind of search. Around the visualization, it's just the search part on which I'm working. So hopefully I'll be able to make some update on that. Yeah, so these are a few features. I think that's all I had from my side. These are some coordinates. If I want to reach out, more than happy to help. Any question?
How long have you been working on your tool?
6 or 9 months.
9 months, okay.
If you guys have any clicked any picture.
That's a beautiful baby you got there.
Is this your day job or this is like a after?
It's a job, it's a weekend hobby, not a job.
So to get more info from GitHub or others, you'll need access, right? So basically in those variables, you should set up your credentials to GitHub and other apps, and extract. I mean, I haven't dig deeper, but you extract the configurations and then analyze, or how you do that.
So from the technology perspective, I think it's very simple. So all of the technologies I have configured, they have API services one way or another, and I'm just taking the authentication detail, making the query to the API, fetching the data, storing it.
So you're fetching it and storing it on your
Local
machine.
database, yes.
And the permissions for those integration accounts, you're also specifying minimum requirements, something.
So it's a read permission to all of the services in a very broad sense. I really don't need anything to write, but I need to read everything into the target technologies. So for example, if you are configuring GitHub, then I need to understand how many users are there, how many groups or teams are there.
So it's not just a read. You need a bit more to see the users.
That's a comprehensive read permission.
You should be an organization kind of admin, read admin.
Yes, yes. It's the permission since the script, the objective of script to read everything. So by definition, it is supposed to have a relatively higher level.
But for this to work, you need more permission.
Yes, agree. I think it's a concern in.
It's
But it's what it is. Any other question?
I can't wait to try it. It's very cool.
I'll love to. Feel free to share any feedback, any question. I'll more than happy to help.
And those rules, I don't know properly to call it rules or whatever. So any inconsistency, say you find vulnerability or something, you have kind of a rule engine, right? So it just checks, okay, for instance, this plugin or whatever known for C, whatever, and that's why it's red. So you have kind of, these rules are configurable, so we can write our own there.
As of today, no. Yes, I think that is one of the limitations you can see that I have just in a way hard coded into the.
Okay, yeah, hard coded.
In the logic of detecting vulnerability is hard coded, but.
I mean, not only vulnerabilities, any misconfigurations, blah, blah, blah. So it's all kind of
security flaws in generally category, it's hard.
Yeah, because there are kind of a bit similar tools, but on another topic, where you actually are able to write your own rules, your own selects or whatever, and check for specific things like, hey, these things, if it's not like this, or this is bad.
No, it does not have that capability yet, but I think that's a good point.
Yeah, this could be a roadmap.
Yeah. As of today, it will either report everything or.
But if you want community to jump on that, and they'll start developing it together. So yeah, it'll be useful.
Yeah, I think on just to add to that, in many scenarios, not all vulnerabilities will be applicable to all organizations. There will always be scenario where it will be acceptable kind of scenario. So let's say I report that as per the tool, it reports that you are using a vulnerable version of plugins in case of Jenkins, but in some scenario there might not be updated version at all. So this does not do that kind of check, like whether there is actually updated version or not.
I think some commercial vendors are looking at this direction into CI/CD thing.
Yeah,
I'm not aware of how deeply they are there.
Palo Alto bought an Israeli company that was, such as a B.
Could be, they have they already have this cloud security posture management thing, right? So this is, let's say, CI/CD kind of posture management.
Yeah.
So that's a kind of continue of the same.
Yeah, for example, in CSPL there is a check whether the identified credential is actually working. Like they do that check. Cool, thank you everyone. Have a nice
Thank you.
day. Bye.